Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and privilege to be serving you, as it is every day here inside my virtual classroom. If you step on inside, I'm going to teach you a little something, perhaps. Let's see, today's video here, I didn't plan on making another video, but my students they didn't force it upon me at all. This was something I decided based on helping them as best as possible. They're going to have a test soon on solving linear systems, and I want to be able to answer their questions that they've asked me. You know that I've made Q&A videos in the past, and when I do, they would take a bunch of questions. Normally I would handwrite them back to them, but then I would take a couple of the questions and I'd make a video out of it, like 5 to 10 of them, and extrapolate further. What I decided to do here was take all of their questions and respond to them in a single video. I have them all provided right here, and what you're going to see on these questions here are just the way that they wrote the questions. I just typed them out. There's no discernible order, no alphabetical, no from this to that in terms of context or anything else. They're just typed out exactly as they wrote them, down to misspellings and everything. So, or lack of question marks or punctuation, just anything like that. I haven't gotten good enough time to look at the questions. I was listening to music while typing them and it just sort of way. I think I saw some duplicates though, so if I run into a question that I've seen before, I might go a little more on like I've already answered it, but blah, 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 here's what you do, okay? I'm going to be able to use the whiteboard thing in a couple times when people ask me questions, but I want to try and go as fast as possible. Someday I'll set like a minute timer for myself on each question and just boom, 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 because I have a lot of them. You'll see the series of questions right here, go all the way down to right there. So I have a bunch of questions I want to answer here, and let's go ahead and get started. Do you have a guide to all the different forms, slope, intercept, standard, etc., and what they're for and how to convert into other forms? It just so happens that I do. If you go onto my YouTube channel and find my videos, I have a video, I think it's called Forms of Linear Equations. And what I do have on that is this nice big splash screen. And it shows, like by splash screen, I mean stuff looks like it's just thrown onto there. At the very beginning of the video, Forms of Linear Equations, you'll find standard form, slope-intercept form, and point-slope form. And then you'll see me graph them and sometimes convert them as well. That screen talks about standard form, what it's best used for. You know, standard form is no fractions. It looks proper. I make equations with them. I can find intercepts. And I'm answering your question, by the way, a little bit too. Slope-intercept form, the M and the B are your rise over run and your y-intercept, and they're good numbers for graphing, and they answer questions for rate in word problems, and you know, I pay $5 an hour, and I hire them for $40. Things like that. Point slope form's a little iffy, a little different. We're not really talking about that here in solving systems, but if you look at that splash screen, I kind of spend a few minutes going over that one screen, and I think that I talk about there in great detail. I'm just going to go and check it off like that I've answered it. Okay. Second question here. I have a question for you about how to draw a graph. Okay, so in this, I mean, there are a lot of different ways to talk about. Let's talk about standard form and slope-intercept form. Those are the two key ones that we're really doing here. First of all, keep this in mind. If you ever want to draw a graph, you can always use a table. Plug in values for x, get values out for y. You make your choices and you go on through. What I'll do here, actually, I'm going to pop up a graph. There we go. Nice big graph guy right here. And I'm going to go here and draw a graph thing for you. Let's say I use standard form and I have an equation such as 3x minus 4y equals 12. This is standard form, by the way. The benefit of standard form is that I can solve using the intercepts very fast. It's a method I call hide and divide. In intercepts, the x and y intercepts, you have a value of 0 for one of the guys, and the other guy you find by substituting 0. If I want to find the x-intercept right here, I'm going to sub 0 for y. That means y goes away. Negative 4 times 0 is 0, so I hide it. Now I have an equation that says 3x equals 12. I divide by 3, I get x equals 4. I divide it. Hide and divide. That's a point on my graph right there. The y-intercept, I'm going to set x equal to 0, and 3 times 0 is 0, so that goes away. I get negative 4y equals 12. I divide both sides by negative 4. I get y equals negative 3. 0, negative 3 is a point on my graph. 2 points make a line. That's all you need. You only need 2 points to make a line, and that's what I found right there, and I can go ahead and use that to draw my graph from there. So I just connect those dots. If I use a ruler, some sort of straight edge or something, I'll be set to go. That's the benefit of standard form. that I can just hide and divide. I can do this all mentally and I get those numbers. Now the drawback is if one of these numbers is, say, not divisible by your constant. Let's say this was -5 instead. Would I really like to divide this by -5 and get -2.4 for that and plot that? Maybe. But if you don't have a calculator and you're not sure how to find it, it's a little trickier. And you know, sometimes you're just dealt what you have and that's all you can use. You know what I mean? So sometimes you can't do anything about that. So that's standard form. Slope-intercept form is most people's preferred because the numbers clearly show you what you're going to do on your thing. Let's say I have y equals 1/2 x minus 4. This is slope-intercept form. Slope-intercept form. In slope-intercept form, you have two numbers. One is the slope, which you like to write as a fraction. One is the y-intercept. We know that y-intercept is the value of y when x equals 0 right here, so 0, -4. And this is all about rise over run. This 1 is me going up 1. This rise is me going up 1. This run is me going over 2. That's another point that's on my graph. Not going to explain why in this video. You asked how, and this is how we're going to do it. We go up 1 over 2 and plot points. And we can go down 1 and left 2 because those are both negatives. -1 over -2 is still +1/2. You plot those and then boom, you draw that for a line. If your slope is negative, like a -1 over 2 instead, then you would go down 1 as you go right 2. You would end up going this way instead, and that's the graph. That's the short way I'm going to talk about how to graph those. Otherwise, you can use a table. I hope that that does happen to clear that one up, though, for you, because I want to keep moving on to the, hang on a second. No, I don't want to do that. To the next question here. Okay, third question. Where do I check this thing off? Hang on a second. This is new for me doing that. Help me solve two-step equations. Okay, so this goes to the old days of, you know, solving two. Okay, what does a two-step equation mean? It means a linear equation, something like where we have 2x plus 3 equals 15, and we solve for x. The two steps involved have to do with getting x all by itself. So how do you solve two-step equations? I can say how to solve this equation, but I want to tell you generally, you get x by itself, and you do that by doing inverse operations on your other numbers so they go away on that side of the equation. This plus 3 is on the same side of the equation as x. I want it to go away on this side, so I have to subtract that 3 over. Why? Because it's added. 3 minus 3 gives me 0. It goes away. And anything I do to one side, I have to do to the other. Now this 2 is multiplying by x right here. I want the 2 to go away. In order for it to say x equals, that really means 1x equals, which means I need to turn this 2 into a 1. So I divide it by 2. 2 divided by 2 is 1, so I divide this by 2 and I get x equals 6. So how do you solve two-step equations? With two steps. Both of them involve getting your variable by itself, and they involve using the inverse operation of whatever's applied there. That's as much as I'm going to say with it, except for like if you have x divided by 2 equals 10, I would now multiply by 2 because it was dividing by 2. So you do the opposite of what's being applied to x so you can get it alone. And that's basically the crux of what's going on in solving two-step equations. But again, I'm not going to go into great detail on that. I'm really about, right now, answering the systems questions or something that applies to them a lot here. How come when the equation, hang on, let me check that one off as well. Oh, looks like when I check those off, they don't go away. I'm good. Let's keep going. How come when the equation is like 5x plus the quantity 3x plus 1 equals something, why don't you add 5 plus 3x and 5 plus 1? Well, you do add 5 with 3x. Oh, okay, you're asking, oh, okay. So you're asking, why don't we distribute the 5 into these things here? Well, the answer is going to come in many forms here, and I don't want to spend too long on it, but I do want to answer your question. First thing is you have to understand that when we distribute, that's because it's multiplication. Don't let the parentheses fool you into thinking that it's anything else other than a grouping and just a quantity right now. It doesn't mean multiplication if you're not multiplying. You know what I mean? That's the first concept. So let me just, if I have 5 parentheses 3x plus 1, I don't see a dot for times right here, but this is implied. It's telling me that multiplication is going to happen. So that's the first thing. We do distribute with multiplication only. This is not multiplication, therefore it's not distribution. But I don't know if that really fully answers your question. To jump further into this, there's no effect with these parentheses because nothing's multiplying to it. So it's like as if they go away. Maybe that kind of helps answer your question. Or the other thing to answer your question here is, if you're asking why don't we do the same thing here as we do with multiplication, the real answer is we actually are doing the same thing, except one's multiplying and one's adding. When this is multiplying, I'm saying I'm multiplying 5 with this. When it's adding, it's saying I'm adding 5 with this. But that doesn't really answer your question. So to dig deeper into it, just give me one more minute here, dig deeper into it, you have to think of multiplication as something different other than what it is that you see. In other words, when I say 5 times 3x plus 1, there's another way of writing that. That's 3x plus 1 plus 3x plus 1 plus 3x plus 1 5 times. Now, I don't see a 5 here anywhere because what 5 really is, it's a way of describing how many times I'm adding my number. So, I can't really answer your question fully in the way that you want to, but when I write 5 plus 3x plus 1, that's just a statement. That just says I'm going to add 5 with 3x with 1. Here, this says I'm going to add 3x with 1 5 times. And so I'm really doing addition the entire time, but when I add these 5 3x's, I get 15x, just like when you distribute. And when I add these 5 1's, I get 5, just like when I distribute. Here, this is all addition. So it's all under one umbrella. There's no distribution to be had because there's no multiplication. And we do distribute with multiplication because we're describing how many times we add those things over together. That's the best way I can answer that question in a short realm, and I hope that covered that as good as possible. Okay, the next question here. How do I do point slope form to a slope-intercept form? Like, can you write the steps so I can always follow the steps? Okay, so they're asking how do you convert? How do you convert from point slope form to slope-intercept form? And I know what you're asking here, and I'd be happy to answer it, but in answering it, I want to tell you that you don't want a cookbook recipe idea on how to convert one to another. It's not a memorization tactic. So you're asking how to go from something that looks like this into something that looks like this. And the best way for me to answer it to you is in terms of what's called generalizability. In other words, I want to give you the general sense in what's going on so you can answer these no matter what form it is. Not everything's in point slope form for you to go to slope-intercept form. Maybe it's standard form. Maybe it's an unknown, unnamed form. But how do you get things in this form in general? Well, from point slope form, look at what things are in common and what things are different. The y is the same, the x is the same, and the m is the same. What's different? This has a b, this has a y1, x1, and this has parentheses. Okay? Same and different. What's the same? We want to keep the same. I want to keep y on the left side of the equation. I want to keep x on the right side of the equation. I want to keep m multiplying by x, as it does. Now, I don't want a y1 anymore, I don't want an x1 anymore, and I don't want parentheses anymore. So what do we have to do? Step 1 would be get rid of the parentheses by distributing. Step 1 is distribute. Get the parentheses out of there. And this is an important step because when it comes to moving this term over, that'll be step 2. Isolate y by adding that y1 over. When it comes to step 2, this y1 I get to combine like terms. I get to combine like terms with whatever distributes there. So let's use a real life example and I'll be done with it after that. So I'll do y minus 2 equals 3 times x plus 4, like this. Let's rewrite this in slope-intercept form. Step 1, distribute. Get the parentheses out of the way. Make sure that your slope still multiplies with x. So I'll have y minus 2 equals 3x plus 12. Now, step 2, isolate y. I'm going to go ahead and add this 2 over, and notice the 2 is going to combine like terms with the 12, and I'm going to get y equals 3x plus 14. So I got it by itself there. You might have more questions on what happens if it's a fraction, anything else like that. I'm not going to really be able to play with that, but as far as the steps, that's what you do. Basically, y equals mx plus b means y is isolated, and this side is simplified. No parentheses, all like terms combined. X term first. Once you get it there, you're set. That's it. All right, thanks for asking that question there. Next question, what is the difference between a bar graph and a number graph, and why are they important in the mathematical subject? Ooh, big words. I don't really know if this is something I want to answer too much when it comes to systems and such. What's the difference? Well, to answer the last question, why are they important in the mathematical subject? Graphs aren't always important in the mathematical subject. Remember, graphs are used to talk about everything else. Okay, what are graphs? They are a visual way of representing data. They are a visual way of representing data. If I have a bar graph and I say, the projections are high here, as you can see, for our toilet sales, or whatever you're talking about, chocolate sales, I don't know what you're talking about. I'm not talking about math, I'm talking about chocolate. So why are they important in mathematical stuff? We use math to make them happen, but we use the graphs to analyze something else entirely. It could be about driving a taxi cab. It could be about running up a mountain. It could be about losing weight. Now, what's the difference between bar graph and number graph? They're just different visuals in what you're trying to do. What I like about bar graphs is you can compare heights of two different things right next to each other really well. I'm not going to draw these things. You can compare heights of two different things right next to each other very well. Oh, here's African Americans and scores, and here's Hispanics and scores on tests. Here's a height, like, I mean, you're comparing two different things in categorical ways. That's the other nice thing about bar graphs. You can do categorical ways. I don't know what you mean by number graphs. I don't know if you mean scatter plots, the graphs that we're making and stuff, but you can make better connections between 2 points in a relationship and such as well. That's so much as I'm going to say on that. Thanks for asking the question, but I want to really talk more about systems, but really talk about why are they important in the mathematical subject? They're really important for every other subject. You analyze that, you make graphs through math, but you analyze the graph for whatever it is you're talking about. For example, if the equation is y equals x, how would the x and y graph? Okay, so this is a good question. If I have the equation y equals x, how do I graph it? So y equals x, is this in slope-intercept form? Is this y equals mx plus b? And the thing is, it is, but what is your m and what is your b if I can't see them? And this is a good question because the m is 1. If I can't see it, it's implied it's a 1. And if I can't see the b, it's implied that I'm adding 0. So that means that my slope here is 1 or 1 over 1, and my y-intercept, let me do it this way, equals 1 over 1, and my y-intercept is going to be at 0, 0. My b is at 0, 0. So how do I graph that? I start at the origin and I go up 1 over 1. Let me grab that graph thing that I had last time here. Where did it go? I'm trying to paste it. Paste, there it goes. All right, so my graph thing right here. Y equals x, y equals x. Now there's another way to graph this. It's going to be really simple. But you start at the origin, 0, 0, and I go up 1 over 1 and plot the points on the graph like this. Okay. Now here's the really easy way to graph it. Now I'm not going to say use a table, but look at this table, and if I plug values in for x, see what you get for y. If I plug in 1 for x, what do I get for y? 1. If I plug in 4 for x, I get 4 for y. 0, 0, -3, -3. Whatever x is, y is. So if I go 4 over on x, I go 4 up on y. If I go -10 up on x, I go 10 down on y. You just plot the points like that. It's a straight line that goes that way. Y equals -x, by the way, would go that way. Whatever x is, y is going to be the opposite. If x is 5, y is -5. But that also means it's a -1 slope. So hopefully that answers your question there. Whoops, let me go like that. Okay, next question here. Thank you for asking that. Next question. When substitution is used and the numbers are flipped, example, and I remember there being an arrow on this question. I forgot to draw it. They drew an arrow kind of like this. I don't know what they meant yet here. For example, 3x plus y, 6. There we go. Does plus become minus? And I saw this question when I typed it out, and I was like, I have to remember to draw the arrow, but I didn't yet decipher it. Okay, when substitution is used and the numbers are flipped, does positive become negative? I think is what they're saying. I don't know how to answer the question that you're asking, but let me answer this question. If I'm trying to isolate a variable, let's say I try to isolate y instead of isolate x here. Let's say I try to isolate y, which means, and I say this a lot, move the 3x over. Some people think of move the 3x over as in doing this. Hang on. As in, hey guys, let's move it over. Whoops, guys, let's move it over here. Here it is, plus 3x. You can't just pick it up and move it over. You have to move it mathematically. right? Moving it mathematically means if this number is positive right now, I have to subtract it. So subtract 3x from both sides, and now I have negative 3x plus 6. So did the positive 3x become a negative 3x? Yes, because I subtracted it over. Does this always happen? It depends on what you're moving over. If this said 4y right here, and I want to move the 4 over, I don't subtract it over. I have to divide it because it's being multiplied. So where does it move? It moves to the denominator, right? Now it moves down here. So it's a kind of different question being asked. It doesn't become negative, it becomes a denominator. So I don't know if that's what you were asking, but that's the only way that I can answer what I think is being asked. I hope that that's okay. But if you're moving things over for substitution purposes and something's added, yes, you subtract it. If it's subtracted on one side, yes, you add it over. You have to make 0 on the side that you're moving it away from. And that's how you do it. You do the opposite. Okay, can you turn no solution equation into a one solution? No. If something has no solution, then you can't manufacture a solution out of it unless you're changing the equation. Let's say I have an equation that says, and I'm not going to get too bold on this, but x plus, how about 2x plus 20 equals, I'm not going to get cute, 2 times x plus 10, and I want to solve for this thing. Oh, wait, I want no solution. X plus 5. Okay, now let's solve for x. I'm going to distribute 2. I get 2x plus 10, and then this equals 2x plus 20, and I subtract 2x from both sides because I want to. Suddenly these cancel out, and you get 20 equals 10, and that's no solution. Can I make this equation so that it has a solution? I can make the equation so it has a solution, but I'd be changing the equation. It's a different equation now. So I don't know if that's answering the question, but I can change this into x plus 10, and suddenly it's going to have an infinite solution set. I could change this into a 3, and suddenly it'll have a solution. You just got to play with it. So I can change things so that they do. And I don't know if you meant system. Maybe you meant system instead of equation. Same kind of thing. No, you can't make, if two lines are parallel and they don't intersect, you can't make them intersect unless you change the equation. So therefore, it's not the same equation. So to answer your question, no. You can't turn a no solution into a one solution. Is there, or what is the name of two lines on a 3D graph that don't have an intercept and are not parallel and are not the same line? I like the question. Let me think about it. What is the name of two lines on a 3D graph? Don't have an intercept. That they don't intersect, maybe? And they're not parallel, not on the same line. Oh, the word is called skew. Let me write this. S-K-E-W. What they're talking about, and I can't draw 3D, and I'm not going to try and, well, I'll try and, okay, picture this. You're sitting in a room right now, whatever room you're sitting in, unless you're watching this outside. Look at the wall that's to the right of you, and look at the line on the wall that's meeting with the wall in the ceiling up top. See that line? Okay. Now I want you to picture the bottom right line right there. Are those two lines parallel? Yes, those are both parallel. What this person, he or she's asking here is, what about this line up here? And what about my back wall on the bottom floor? It's like a line that's, here, let me just do this. What about a line that's going like this and a line that's going like this? Are these parallel? Because they don't intersect. Okay, they don't intersect, but they're not running along the same course here. They're not on the same plane. They want to use the word plane here. And that's okay if you don't know this stuff yet, if you're not in geometry, on the same plane. What about like this? They're called skew lines. They're called skew lines. That's all I'm going to say to that. They're called skew lines. All right. Does a negative plus a negative, and you can see I'm doing this on the fly clearly. I did not prep these things here. Does a negative plus a negative make a positive? No. Never. Negative 3 plus negative 5 equals negative 8. It goes further negative. Oh, you can't see me write that. It goes further negative. No. Would a negative plus a positive make a negative or positive? For example, negative 4 plus 2. Well, negative 4 plus 2 is negative 2, so that would make a negative number. That makes negative 2. But they can make positives. What if I do negative 4 plus 8? That's going to be positive 4. So does it make a negative or positive? It depends. Which number's bigger, the negative or the positive? If the negative's bigger, it's going to be a negative. If the positive's bigger, it's going to be positive. And just so you know, because, a lot of people sometimes have trouble doing negative plus and things like that. If it helps, I can rewrite negative 4 plus 8 into 8 minus 4. I can rewrite it, and you know that that's 4. So if you ever want to rewrite them that way, look at 2 minus 4. Is 8 minus 4 positive or negative? Positive. Why? Because 8's bigger. Is 2 minus 4 positive or negative? Negative. Why? Because 2 is smaller than the thing you're subtracting. So small minus big is negative. Big minus small is positive. Something minus itself is 0. So you can also make 0 out of it. Thank you for asking that question, though. Okay. How do you know how to graph it from the placement? From the intercept? I just need help on that. What I'm guessing is being asked is slope-intercept form. So I've answered that one already, but just to go back to the idea, in y equals mx plus b, we start from the y-intercept, okay? Whatever it is, last time I said -4, if your y-intercept is -4, and you use your slope. If your slope is 1/2, we use this as a rise and a run. Again, I'm not going to say why. I just can't tell you. There's a lot to talk about with it. I'm not going to say why. And it has to do with x. But every time I rise 1, I run 2 and plot another point. But now, why do we start from the y-intercept? Because it's a reference point. It's a part of your line. So I'm not starting from the origin and going up 1/2. I'm starting from -4 and going up 1/2 and plotting more points there. And you continue that up 1/2 on that path. Now, here's a question that's not really being asked, but maybe it's a part of it. What if your slope is not a fraction? What if it's 2? You should write it like a fraction. 2 is 2 divided by 1. So starting from -4, I will rise 2, run 1, and go like that. So I'd write it as just divided by 1, and then you run 1. And when I say run, I mean run to the right. I mean go that direction. Okay, next question here. The elimination part is still a little confusing. Okay, so the elimination method is what they're talking about here. The elimination method is actually, it's the process people tend to get actually pretty well, and I want to clarify this one for this person as well. The why you're allowed to do it is something I don't think I get to talk about really right now if I want to go rapid fire, but the elimination method, as simply put, if I have something like this, right here, as long as everything's aligned, okay, here's what I'm going to talk about. As long as everything's aligned, the x's are aligned, the y's are aligned, the equals are aligned, and the constants are aligned, you are allowed to add down these rows, or subtract, or multiply, or divide. But if I add down these rows, it's going to be the cleanest math for myself. And what's good for me here, in this particular instance of these two equations, is positive y and negative y. When I add, I'm doing y minus y, and they cancel out. And the great part about this is I end up being able to solve for x in this nice big bad way. So I solve for x through elimination. This was an easier problem because these were additive inverses already. I think I recall there being some questions on manipulation of equations later, and I will get into them. But let's say this didn't look like this. Instead, it was 2x plus 2y equals 7, and 3x minus y equals 8. Suddenly, I can't add down these lists and cancel anything out anymore. Notice the y still appears because 2y minus y is y. So I need to find a way to cancel a variable for myself here. And what I would choose to do instead, is find a way to eliminate this y. What if I did make it -2y? I can't just do that though. This is a full equation where I only changed one number. I have to change all my numbers. So I can't just make this a 2y, but I did make it 2 times bigger. So if I make this 2 times bigger and this 2 times bigger like that, suddenly I can do that elimination again. So I multiply everything by 2, and I'm sure I'm going to do some examples of that down the line, but that's the idea of elimination, is as long as everything's lined up, find a way to add and cancel out a variable by making it 0. If you have 4y, -4y, or -2x and +2x, cancel them so you can solve the other variable. That's your main objective. Get a variable by itself and go. That's a good question, and it's, when I'm going rapid fire, I can't really do too much of it because I'm already hitting the half-hour mark here, and I'm sure I didn't cover half the questions yet. So I'm going to keep on moving on. How do I point multiple points on a graph when I only know one point? It's a lot of points there. How do I plot? How about plot? You can't read that word. How do I plot multiple points on a graph when I only know one point? How about that? What I'm guessing is being asked again is slope-intercept form. So to answer the question again, starting from the y-intercept, with that slope you do that rise over run. If my slope is 2/3, I'm going to, from some point that I know, like my y-intercept, I'm going to rise 2 and I'm going to run 3. rise 2, run 3, plot a point. Rise 2, run 3, plot a point. And that's how I'm going to go on that. I'm not going to say too much more on that because that is what we talked about before. You can find the previous question there. How would we know which equation to isolate or substitute? So if we're talking about substitution method and no variable is isolated for you, how would we know what to isolate? Well, let's go to that previous problem I did. 2x plus y equals 7 and 3x minus y equals 8. How would I know which variable to isolate? I would say prioritize in this format. Number 1, try and find a variable that has a positive 1 coefficient. In this particular problem, I have one here, positive 1y. I would get that one by itself because it's the fastest. I only have to do one step to get it by itself. I have to subtract 2x over. Okay, but say it wasn't. Say it was a 2y, just like that other example I said. Now which one would I choose? If there's a negative 1 coefficient, I'd try and find that one. See this negative y? I'd like to get that by itself. Yes, I have to subtract 3x over, but now all I got to do is switch all my signs, multiply everything by negative 1, and suddenly all my signs change. Not too bad. The reason why I say choose one of those is because it's a sign switch from here, that's it. And also you can guarantee no fractions come into play. Okay, now what if that's not in play though? What if, and I'm gonna have to change some numbers now that we have something else here, if you don't mind. Let's go and do a different kind of problem now. What if we don't have a positive or negative 1 coefficient here? That did not want to delete for me. What if instead we have, delete, thank you. What if instead we have 2x plus 4y equals 10 and 3x minus 5y equals 7. Now which one do I do? Look at all your different coefficients in here, the 2, the 4, the 3, and the negative 5. Look at them with respect to their equation. Let me do that again. Let me have different colors here. Look at them with respect to their equation. When I divide, if I solve for one of these variables here, if I want to solve for this x, get x by itself, that means eventually I have to divide everything by 2. In this equation. Can I divide 4 by 2 and 10 by 2 cleanly and not have fractions? Yes. If I got this y by itself, I'd have to divide everything by 4 at some point. Can I divide 2 and 10 by 4 and have everything come out cleanly? No. Same with dividing 3, an issue for 5 and 7, and with 5, an issue with 3 and 7. So my next thing is to find the one that when you divide everything out, there are no fractions. All right, I would isolate the x by dividing that 2 out. So those are kind of the steps I'd go to. Last but not least, if everything would be a fraction, just do the best you can. Least amount of fractions, most amount of positives, anything that would help you out best there. Because after that, you're a little SOL, if you know what I mean there. All right, cool. Are there any other ways to solve linear systems other than what we've already learned? You've learned solve by graphing, find the points of intersection. Solve by substitution, isolate a variable, plug things in, yada yada. Solve by elimination, cancel out the rows. Are there any other ways? Not that I'm going to teach you. Once you get in about pre-calc or so, you'll probably learn something called matrices. It's not a way that you're going to want to solve unless it's larger systems or unless there's something else in play. But there's this word, you can look it up. You're not going to know anything about it right now. They're called matrices. So is there another way? Yes. And within matrices, there are these methods. There's something called Gaussian elimination. There's something called Cramer's rule. There are a lot of different things you can do with matrices. To just a nice little pinpoint, matrices look like these things right here where there are numbers inside and you do things with them. I don't know. I'm not going to write a lot of stuff on them. But matrices. Outside of that, I don't think so. Guess and check. Logic. That's all I got. Which equations do we know to substitute? So this, this is not like the last question for isolating. Which equations do we know to substitute? So if you have a system of equations here, okay, let's do that last problem we did. 2x plus 4y equals 10 and 3x minus 5y equals 7. Let's say that I did isolate x, subtract 4y, and divide by 2. X equals negative 2y plus 5. Where do I substitute negative 2y plus 5 in for x? Can I plug it into this equation or that equation? The answer is no. You have to do the other equation. Okay? If I isolated this equation right here on top, I have to plug it into the bottom one because it generates new information for you. Okay? If I plug it into the top equation, here's what happens. 2 times negative 2y plus 5 plus 4y equals 10. I distribute negative 4y plus 10 plus 4y equals 10. I combine like terms, negative 4y plus 4y goes away, I get 10 equals 10. Infinite number of solutions. What I did was I substituted a re-representation of my equation back into itself. I'm substituting me for me. Nothing else, nothing's changing, nothing's happening. It's not new information, nothing else is coming out. We need to plug it into new information here. It's like if I had two equations, it's like if I had a scenario, I know I've said this kind of thing to my students, but it's like if I had a scenario that said the number of boys and girls in a class is 30. And then I also said, oh, and guys, by the way, the number of girls, you can find the number of girls by taking away the number of boys from 30. How many girls and boys are there in the class? I didn't give you new information to help you answer that question. And it's not that the answer is 15 and 15. It could be 10 and 20, whatever. But I didn't give you new information. I'd have to say something like, there are twice as many girls as there are boys. Something like that. New information has to present to you in order to answer that. So it has to go in the other equation. It has to go in the other equation for you to actually solve for something if you want to. What are other methods we are going to learn? So that goes back to the idea. Solving systems of equations. You're not going to learn any more from me. Graphing, substitution, and elimination are the ones. The big one's substitution. I'll be honest. Substitution is the big one because you always do graphing's important too. But the big one's substitution because we always substitute no matter what we do. And with all different types of systems, you are going to solve by substitution. Graphing will be used a lot, but you're going to have to learn a lot about how to graph different ways like quadratics and rational functions and things like that. So you can leave that on the back burner. And elimination, one of the cons is the only time I want to solve using eliminations is with linear systems, not with quadratics and all these other things. It gets a little messy. So what other methods? You're not going to learn any from me. Eventually, you'll probably learn solving with matrices, depending on the curriculum and the teacher and stuff. Matrices is the other one. What's the difference between no solution and infinite? Well, besides everything, because no solution means you can't run into anything. Basically, what does it look like, maybe? I guess what you're asking. A no solution case on a graph. No solution case on a graph is when your two lines are parallel. So that means they have the same slope, but they have a different y-intercept. Those aren't exactly parallel, but you know what I mean. An infinite number of solutions is when you have one line, and then another line runs on the same path, but it's not parallel because it goes right on top of it. So what if I have this line right here, and then I have another line that I'm going to thin out, make a different color, and I put right on top of it right here? That's an infinite number of solutions. No solution means your graphs never intersect. Infinite number of solutions means your graphs intersect everywhere. Okay, that means same slope, same y-intercept. Now, what does it look like when you're solving equations if you're using substitution or elimination? The no solution case looks like something where the left side does not equal the right side. You get something like 0 equals 2. Clearly does not work. The variables cancel. There's no single x or single y, and you get something like that. An infinite number of solution case looks like something like 0 equals 0 or 7 equals 7, where the left side equals the right side, and suddenly the x and y's cancel, and it looks like that. So that's the end result when you solve them through there. Graphically, parallel, never intersect, that's no solution. Right on top of each other, intersect everywhere, infinite number of solutions. And those happen when you have the same slope. Same slope, different y-intercept, same slope, same y-intercept. So hopefully that answered that question there. All right. Do people use other letters like A and B instead of X and Y? If they do, how do you know which to list first, like how X and Y? Basically, I think they're asking, how do they know which one belongs for the actual X-axis and Y-axis? Well, if it's a word problem, what I would say is determine what that independent variable is. You know, how one thing kind of depends on another? You know, the cab fare depends on how many miles you drive. So miles is kind of, even if I use M for miles and F for cab fare, my M is kind of like my independent, like my X, and my F is kind of like my dependent, like my Y. So I type MF, like, you know, so I do M comma F. So otherwise, it doesn't matter. If there's no dependent independent, if it's the number of burgers and hot dogs, it doesn't matter. Just be consistent with one versus the other. I'd say go alphabetical if you could. B and H, burgers as X, hot dogs as Y. Otherwise, if there's a true independent like time is generally true independent, or dollars is generally true dependent, I would go based off that. So it depends on how you define your variables, if something's dependent or not, and if it's not, it doesn't matter. Just make sure you're consistent. If I state one is one is the other, this, that. But that's why in word problems, we don't really answer the question as an ordered pair. I state there were 5 burgers and 10 hot dogs. I don't say 5, 10. So if it's a word problem case, we do that. Do we use A and B when it's not a word problem in that context? Not so much. The alternative is if you're using x and f of x instead of y, but f of x takes y's place. Okay, next question. When you try and plug in the variable you found into one of the equation, does it matter what equation you substitute the x or y that was found? So this is different from the previous question that was asked once you isolate a variable, what happens? This is once you solve a variable. If I solve for x in something, does it matter which equation I plug it in after to solve for y? The answer is no. Are there better ones than other? Are there some better ones to plug in than others? Most often, yes. Which ones? It depends on if you're trying to find more positive numbers, smaller numbers, one where y is already isolated, things like that. Let's go to that one example that I played with. Where am I going? Let's find that one example that I did here before. The 2x plus 4y equals 10, 3x minus 5y equals 7. By the way, I can't guarantee you there's a good integer solution thing here. But let's say I get x by itself. I get negative 2y plus 5. And let's say I plug it in and I solve for y. And let's say I got y equals 4. All right, let's say I got y equals 4. I don't know if that's the answer. It's probably not. Let's say I got y equals 4. Where do I plug this y into? Because I have 3 different places I can plug it in. As opposed to the previous question, when we isolate a variable, I can only put this into that x right there. When I solve for y, I have 3 places I can plug it in. 1, 2, 3. Yes, you can use a rewritten form of your equation. Which one would I plug it in? Oh, I would do this one because I'm trying to solve for x, and I want an equation that says x equals. I get negative 8 plus 5, negative 3. I'm done. I don't have to plug it in and then move something over and then divide and then make that happen. I already have x by itself. Which one would I do among these two? That's a good question. Both of these numbers are maybe slightly small. That's a good question. You say negative here, but if I add it over, suddenly it's a positive. So that's kind of it doesn't really matter. So can you do it in any of them? Yes. Which one would you want to do it for? If you have a variable isolated, I'd do that one. Otherwise, try and find the smaller numbers or one with no fractions or less negatives or whatever. But you should get the same answer. You're going to get the same answer for x no matter what you do, as long as you do the right math. Okay, how do you... You know what? I typed this wrong. This should say minute. This should say minus. That's my fault. I'm sorry. How do you minus or plus one fraction with another fraction? How do you reduce a fraction? Okay, so that's 2 different questions in play here. And, we are dealing with some fractions in class here. But when we do, generally I find a way for us to clear it. Like we clear the fraction. But they're asking, hey, how do we do 2/5 plus 1/5? Let's do an easy one first. Simple. If you have a common denominator, you add across the top. To make sense of this, why you need a common denominator, and I really want you to understand this, what if I do 2 plus 1? You know that answer is 3. How come? Because this is 2 over 1 plus 1 over 1, and that equals 3 over 1. 2 wholes plus 1 whole equals 3 wholes. A better way to talk about it is you want to compare things on the same level, and I always like to talk about pizza slices with it. Not going to get deep into that. But how do you do it if you don't have a common denominator? You get a common denominator. So how about 2/5 plus 1/4? Suddenly, how do I go about adding these two? They're not alike. 2 slices out of 5 is not equivalent to 1 slice out of 4 in any sort of way that I can compare justly. I want to compare them. So I need to get a common denominator. I want to find the number. I want to find a number that is common for both of these if I can multiply top and bottom by something. The reason why we multiply top and bottom by the same number is because, and I'll show you right now, it's going to be 5 here and 4 here. 5 divided by 5 is 1. I want to multiply 1/4 by 1 because it doesn't change my number. I'm rewriting its expression. So anyway, I can't get too deep into it. Just going to multiply straight across. 4 times 2 is 8. 4 times 5 is 20. 1 times 5 is 5. 4 times 5 is 20. So now I have the common denominator, and then I go ahead and add, and I get 13 over 20, etc. Things like that. Okay. How do you subtract? Same exact thing. You just subtract instead of add. Now your next question, how do you reduce a fraction? Well, if you noticed, I went from 2/5 to 8/20. So I actually grew my fraction in this case. Now, how do you go from 8/20ths to 2/5? Notice that 8/20ths is 2/5, right? Because 2/5 times 1 is 8/20ths. You got to find a number that can divide on top and bottom by something. 8 and 20 can both divide by 4, so I divide both of them by 4 to make that happen. All right. When I get the number, if I have 26 over 84, I don't know if this will pan out to anything good, but I can divide top and bottom by 2 because, again, dividing by 2 over 2 is dividing by 1. I don't want to change its value. I just want to change the way it looks. This becomes 13 over 42, so I reduce the fraction. How do you reduce? You divide top and bottom by a same thing, as long as both numbers can divide by that same thing. 2/4 is 1/2 because I can divide both top and bottom by 2. All right, so there's that question there. Next question here. For elimination, how do you know if you need to manipulate both equations? This might have been one of the ones I was talking about that I said we have to do it again. It actually kind of comes to the last question that I had there. How do you know if you have to manipulate both equations? Well, let's let me clear what was there last. Hang on. Clear. Bye-bye. Okay, so how do you manipulate both? How do you know when you manipulate both equations? Or if you need to. So 2x plus 5y equals 10, negative 3x plus 4y equals 12. You've seen me before say, well, if I can multiply by something to get an additive inverse, I'm good. But the problem here is, on these things right here, is if I wanted to cancel out my x's, what do I multiply 2 by to make this a 3x, right? What do I multiply 2x by to make this a 3x? The answer is it's a decimal or fraction, 3/2. And I don't dare want to multiply by 3/2 here or here. Well, it's not too bad there. But I don't want to have to look for that number. So the thing is, I don't want to change this into a 3x. I want to change this into a number that negative 3x can also change into a number so that they both cancel. How do you know if you need to manipulate both equations? If I can't multiply just by one equation to match another number. Same with 4. I can't multiply 4 by an integer to make 5. I'd have to multiply this by 5 and this by 4 to make them both be 20. You know what I mean? So I can multiply this top one by 3 and this bottom one by 2, and suddenly I got a 6x and a negative 6x, and then I can cancel. But I know that because I know that one can't multiply into the other. Basically, 3 is not a multiple of 2. But 6 is a common multiple of both 2 and 3. So that's how we figured that one out. You look at it and then you decide for yourself if you can or can't. I don't know about the infinite number. I assume they're not talking about infinity in itself. I assume they're talking about an infinite number of solutions. So I talked about that before in several ways. Let me just talk about it again. An infinite number of solutions does mean that you have two lines that are actually the exact same line. One is on top of another, which means they're intersecting with every single point that exists for them with every solution. All infinite number solutions means, see, a line is just a bunch of points. A line is a bunch of points, and all those points are solutions to your equation. What's the solution to this line and another line that's right on top of it? All of those points. How many points are there? There's an infinite number. That's why there's an infinite number of solutions. What does it look like in an equation? 0 equals 0, 2 equals 2, something like that. I answered the question before. If you want to find it again, you may. How do you know when there is a negative number by y? Example, negative 3y equals x plus... No, excuse me, how do you do? How do you do when there's a negative number by y? Example, negative 3y equals x plus 0. Well, I don't know if they mean solve for y, and if they do, it means you divide by a negative. So negative 3y equals x. I don't know if it actually said plus 0. Let's say it said plus 10. Maybe it did. I would divide everything by negative 3. You have to divide by a negative because our goal is to get y, which means positive 1y. And anything divided by itself is 1, except for 0, of course. 0 divided by 0 is not 1. But I got to divide by a negative. If that's what you're asking, that's kind of what we're doing with that there. Now, when you divide by a negative here, this becomes a negative 1/3, and this becomes a negative 10/3. So signs change. These were positive, now they're negative. Things like that. Okay, thanks for asking that. I'm getting to 50 minutes here. Let's see if we can finish this off pretty soon. How are we learning substitution as part of I can't read. Are we learning substitution as part of something bigger? How can we check if our answer is correct? Well, I don't know how the question's really being asked here, and I know that sometimes you want me to infer this in a better way. Substitution will be used in every single math thing that you do, including the bigger maths. So are we using substitution as part of something bigger? Yes. Are we getting into grander forms of substitution? Not really. Once you have a variable isolated, the whole idea of substitution is, like here, when I have, where's my thing? Like here, y equals negative 1/3 x plus minus 10/3. These are identical. These are in this system, or in this equation, these are the exact same thing. Y and negative 1/3 x minus 10/3 are the exact same thing. It's just, so one's taking place of the other. It's substituting. Maybe to you, they're not the same. And I've said this in class for my students. Let's say you have a little brother named Jake. Jake equals your little brother. So if I say a sentence, I can't spell either, like I can't read, your little brother. Let's say I say a sentence that I'm talking to you, and I say, Jake went out to eat. And I say another sentence, and I say, your little brother went out to eat. Your little brother is Jake, so they're the same thing there. So substitution is all about isolating variables so this can take place of that variable. It's going to substitute. I can substitute your little brother in for Jake, and you can know that I meant the same thing, assuming you only have one little brother. Okay. How can we check if our answer is correct? So if you get an ordered pair and you want to know if your answer is correct, there's a lot of ways. The main way is I would take your two numbers. If your answer is 2, 3, I would take the 2 for x and substitute it into x in your equations, your original equations. Take 3 for y, substitute that into your y's in your original equations, and see if the left side equals the right side. You have to do both equations in a system because the point is it needs to work for both, not just for one. Substitute, double check, see if it works. How else do you know if your answer is correct? You can try another method, graph it, and see if it intersects at the same point. Something like that. Just go through your work again. Sometimes logic kicks in too. Like, I don't know how to say it. But yeah, that's how you can check if your answer is correct. How do you change it? If it's incorrect, you have to look through your steps again. So see if your steps worked out the way they're supposed to. Is it smart to multiply by a negative if all numbers in the equation are negative? It depends on what you're doing. If you're doing the elimination method and something's already, 2x plus 3y equals 4 and negative 2x minus 6y equals 0. Negative 10, all negative. No, I wouldn't multiply these by negative 1 because I can eliminate the x's right here. So I wouldn't do it there. How about another scenario? If it's not set up for elimination, would you? In a lot of cases, I would. This isn't the kind of equation you're doing right now, but let's say you had to solve a quadratic equation that said negative x squared minus 6x minus 9 equals 0. I'm in the fan base of multiplying by negative 1 everywhere and getting x squared plus 6x plus 9 equals 0. Remember, 0 times negative 1 is still 0. So I'd rewrite it like this for my own sanity and for my sense here. Sometimes, and you know what else I sacrifice too? I like my leading terms positive. So I'd rather, and remember, this has to be in equations. It's a good thing you said the word equation. You can't take an expression multiply by negative 1 because you changed everything. But if I have an equation, that says negative x plus 2 times like blah, 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 I'd rather have this be positive, equals 4. I'd rather have this be positive and this be negative because me. There's something about my leading terms that I really like to be positive. So, I don't know. Is it smart to? Yeah, it depends on the scenario, but you can only do it with the equations as long as you change everything. I like the question. I know what you're asking. There's that. All right. Is there another way to check your answer? So outside of substituting your things and seeing if there is, again, you can try a different method. You can try graphing if you didn't try graphing yet and go through your work. No, I would just try and substitute the numbers in. I'd try and plug them in and see if that one works there. That's your best way. How can you determine which equation to use to plug in to find x or y? So I don't know if this is asking more in terms of how do I know which variable to isolate? Because I answered these questions already. But how do I know which variable to isolate? Assuming you have coefficients on all of them, find the coefficient that when you divide it out, you have no fractions left out. You have no fractions. I'd try and get no fractions. If you're asking, when I isolate it, which equation do I plug it into after that? The other equation you didn't use. So if I isolate x in the top equation, I got to plug my expression into the x in the bottom equation. If you're asking, if I solve for x, if I get x equals something, which equation do I plug that into? Any equation imaginable that you have. You can plug in any of them and solve for y. I would decide to plug it into 1 if y is already isolated somewhere, or if I have smaller numbers, more positive numbers, something like that. So anyway, all three of those questions were kind of answered. I'm just saying them in a nutshell again because I don't know which one you were asking there. Okay, when dealing with fractions and substitution, how do we cancel them out or rewrite them? So this is a question that's not yet been asked. The previous one was like common denominator, I assume. This one is more like, let's say I do have a scenario, 2x plus 5y equals 1, and 3x minus 4y. And again, I'm not going to solve the whole thing. 3x minus 4y equals 7. Let's say no matter what you do, you're way out of luck when it comes to isolating a variable in terms of you'll get fractions no matter what you do. I'm going to go ahead and isolate this x, though, for the very reason that I'll be left with positives in the end. You're like, wait, there's a negative. Yeah, but if I add 4y over, suddenly it's positive. So I'll get 3x equals 4y plus 7, and then x, if I divide everything by 3, I get x equals 4/3 x plus 7/3. Okay, I have this fraction thing right here. I have to substitute it into, y, not x. I have to substitute it into x in the top equation, okay? So now my equation is going to say 2 times 4/3 y plus 7/3 plus 5y equals 1. I mean, there's no way around that. Now I'm going to distribute my 2. And remember, 2 multiplies with the top numbers here. So I get 8/3 y plus 14/3 plus 5y equals 1. All right, from here you have some options. And here's where the question comes in. How do we cancel them out or rewrite them? One way of dealing with them is actually getting common denominators. I'm actually not going to do that. I am going to cancel them out. How do I do it? You have to look at your numbers that you're dividing by here, and you have to say, whatever I'm dividing by, can I multiply by its opposite to cancel them out? Now, if they're the same number, it's a really easy logical step. If they're both 3, I'm just going to go ahead and multiply everything by 3. If I multiply everything by 3 here and by 3 here, suddenly those 3's cancel. What's 3 times 8/3 y? The 3's cancel, it's just 8y. What's 3 times 14/3? That's just 14. What's 3 times 5y? That's 15y. And 3 times 1 is 3. Now, I'm not going to solve this. It's a weird answer. I made up the problem. But I cancel the fractions by multiplying by the thing that's being divided. So they cancel there when you distribute. Keep in mind the 3 still has to multiply with everything when you do that. Now, what if the numbers were different? What if it was a 3 on one and a 5 on the other? You got to multiply by a common multiple. So I'd have to multiply everything by 15. That one's a little harder to do, in which case maybe you multiply by 3 first and then by 5 second, something like that. It's up to you. If this was a 6, though, you could multiply everything by 6, because 6 can divide by 3. But again, that might be harder to do with what you're doing here, because I have to multiply and then divide by 3. Maybe multiply by 3 first, then by 6. It's up to you. The only downfall of getting rid of the fractions, it's not a bad one, is that the numbers get a little bigger. Depends on them, but the numbers can get bigger. Okay, but you multiply by everything, and I do it after distribution. Do it to the point where you're like, I don't want to find a common denominator, so what should I do? Deal with the fractions for a moment, and then go on that route. Good news is, most people would probably solve by elimination doing this, so you wouldn't have to isolate a variable to do that. The only times that you're going to be forced to solve using substitution is if you probably won't have fractions, if you know what I mean there. If you do have fractions, you probably don't have to solve using substitution. Okay, I have 5 more questions here. When you're trying to find y or x, can you plug it into the bottom or the top? So again, this question's been asked a couple times here. When you're trying to, if you're trying to isolate, if a variable's isolated, you do have to plug it into the other equation. If I isolate x in the top equation, I have to plug it into the bottom x, okay? But if I solved for x, if I got x equals 4, I can substitute that 4 into the top or bottom equation or any rewrite, okay? Hopefully that kind of answers the question. All right, when x equals 4 and you need to graph, is it a straight line down? Yes. X equals 4 is a graph that looks like, oh, I don't have my old graph thing here. I'll just draw a simple graph. X equals 4. Here is where x is 4. 1, 2, 3, 4. Here's where x equals 4. But hey, by the way, here's where x equals 4 too. Here's where x equals 4. Here's where x equals 4. Right? Think about these points. This is 4, -2. This is 4, 20. All of these points are when x equals 4. What is that as a graph? That is a straight line that goes up and down. That's a dark green. Sorry about that. That's a straight line that goes up and down like that as an arrow. X equals 4 is that. Okay, do you have to change the negative or positive in every equation? I don't know what that means. No. If you're asking in the sense, let me do that two-step equation kind of thing. 2x plus 7 equals 27. When I move it to the other side of the equation, does the sign change? Yes. I have to subtract the 7 over if it was added, something like that. I don't really know what you're asking otherwise. If you're talking about elimination method, do you have to have additive inverses on top and bottom, like a 4x and a negative 4x to eliminate? I'd recommend it, because if they're both positive, you'll have to know to subtract all of them. And I've already seen a student try and subtract, and they forgot to subtract some of them. They added some and subtracted others. So yeah, I would make sure to have additive inverses if I'm going to cancel. So if those are one of your two questions, that's how I answer that one there. All right, how many solutions can a linear equation have? Well, there are 3 different sets of solution types an equation can have. It can either have 1, none, or infinite number. Because what you have to remember about linear equations is linear systems. I think what you're asking is linear system. Well, linear systems or linear equations. But a linear system, 1 is when your 2 lines intersect like that. None is when they're parallel and don't intersect at all. And infinite is when one is on top of the other. We've talked about that several times. Now, why can't you have 2? Because this is a line. And in a line, lines don't bend or angle or curve. You can't come back on this part and hit it at another point. You can in a quadratic equation. You can in ones that have curves in an absolute value equation. But linear equations, which generate lines, never-ending lines, by the way, these are the only 3 system sets you can have. Okay, and the last question here is, how do you substitution? One thing takes place of another. So in general, again, if it has to do with systems of equations, I have an isolated y right here, and then I have another equation here that says that. How do you do substitution? How do you substitute? See, when we have a system of equations, and this is where I can get a little bit deeper, when you have a system of equations, we're trying to find the point of intersection. We're saying, what is that 1x, y value where they intersect, if it is one point? And if it is one point, that means it's a single y value. So what we're doing is we're assuming these y's are the same thing. We play on that assumption in order to solve it. That's what we get to do. This y is the same thing as that y. And if y happens to equal 3x minus 4, then 3x minus 4 happens to equal this y as well. In other words, 3x minus 4 can take y's place. Now, how do you substitute in general? You know my saying, when in doubt, use your damn parentheses. There's a minus right here, and in place of y, I got 3x minus 4. And that's how I substitute. I use parentheses, and I have it take place of the thing that it's equal to. If y equals this, this takes place of y. That's what happens. Why does that help? Because I can now solve it. You know what I mean? I distribute the negative. Let's just solve this one because it's the last question. Distribute the negative. That's a plus 4 now. Combine like terms and subtract 4 from both sides, and I get x equals negative 1 there. And then I can use that negative 1, solve for y in that equation, and I'm done. All right, so that ought to do it for this and for me right here. It's kind of fun to do that. I know it was an hour-long video. It was a lot of questions. I'll actually get an official count how many there were here later, I guess. But it was a lot of questions there. It's kind of fun to do. Better to do that for me than to handwrite everything, because I don't know if I answered the question better in full, and I can talk and run a lot through these examples and do it this way. I might do it this way more often. This was kind of fun, but this geared my students toward a test here, and I hope that they genuinely had a question that they need answered, and I hope that I genuinely answered it for them. All right, so that's it for me. My name is Mr. Robinson. Thank you for watching this video in general, because this helps anyone involved who has questions, and as a math teacher, all I want to do is help teach math. You know what I mean? All right, so that's it for me, guys. Take care.